Students, let's see the question number 2 from exercise 3.6. Three questions related to practical sums. Formulate the following problems as a pair of equations and hence find their solution. There are three different types of practical sums are given. The first is Ritu can row downstream 20 km in 2 hours and upstream 4 km in 2 hours. Find her speed of rowing in still water and the speed of the current. We need to find the two speeds. One is speed of her rowing in still water and the speed of current. That's why first of all we have to assume two variables. One is x and one is y. Let us take x kilometer per hour is the speed of rowing in still water and y kilometer per hour is the speed of current. In the question says that Ritu can row downstream 20 km in 2 hours and upstream 4 km in 2 hours. That's why first of all we need to find speed of Ritu upstream and downstream. Speed of Ritu upstream, first given downstream, then first of all we write for our downstream because first is for downstream. Speed of Ritu downstream. Downstream means in same direction. Addition x plus y kilometer per hour and same way speed of Ritu upstream is equals to x minus y kilometer per hour. We subtract the speed of current from the speed of a person, speed of Ritu. Now the first condition says that Ritu can row downstream 20 km in 2 hours. As we know, the speed is equal to distance upon time. Here we are taking here speed, but the speed of downstream, the speed of downstream is a x plus y. X plus y is equal to the distance. Distance is a 20 km and time is 2 hours. 20 upon 2. Cut is possible, 2 tens are. That's why x plus y is equal to 10, which is our first equation. To obtain the second equation, we take the same procedure here. The second condition says that and upstream 4 km and 2 hours. Now again Ritu can row upstream 4 km in 2 hours. Again we are using here speed is equals to distance upon time, but the formula speed is equals to distance upon time, there is no need to write again. Speed in upstream is x minus y is equals to distance. The distance is a 4 km and the time is 2. 2 to the 4. That's why our equation is x minus y is equals to 2, which is our second equation. See, the directly addition is possible, then the y is eliminated here. Add equation 1 and equation 2. Addition of left hand side and the addition of right hand side. Open the brackets. Is 12 plus minus y is cut, x plus x is 2x is equals to 12 x is equals to 12 upon 2, 2 6 are 12. Value of x is 6 here. To obtain the value of y, we substitute x is equals to 6 in the equation number 1. Substitute x is equals to 6 in equation number 1. Our first equation is x plus y is equals to 10, where x is 6 plus y is equals to 10. That's why by making y as a subject, we get 10 minus 6 and y is equals to 4. And we obtain both the speed. Speed of rowing in still water is a x 6 km per hour and the y km per hour is the speed of current, which is 4 km per hour. Therefore, answer in sentence is compulsory. Ritu's speed of rowing in still water is the x km per hour. Value of x is 6 km per hour, and the speed of the current is the value of y km per hour is the speed of current, which is y 4 km per hour. See the verification. 6 plus 4 is equals to 10 and 6 minus 4 is equals to 2. Hence the solution is verified here. The solution is x is equals to 6 and y is equals to 4, but correct answer compulsory write in the sentence. Now we see the next number. See the next second number. Second number is the most important practical sum. 2 women and 5 men can together finish an embroidery work in 4 days, while 3 women and 6 men can finish it in 3 days. Find the time taken by 1 woman alone to finish the work, and also that taken by 1 man alone. First of all, we have to assume the time taken by 1 woman alone to finish the work is x days, and the time taken by 1 man alone to finish the work is y days. Let us take time taken by 1 woman alone to finish the work is x days, and time taken by 1 man alone to finish the work is y days. If we have to take days are x, work done by 1 woman is a complete work, means 1 work is completed. That's why in a 1 day work done by 1 woman, which is 1 upon x, 1 ones are 1 and upon x. 1 upon x is the work done by 1 woman in a 1 day. Therefore, first of all we need to find work done by by 1 woman in 1 day is equals to 1 upon x. How it is possible? Using days are x, then work is complete work means 1. If 1 day, then question mark in work. Same way, work done by 1 man in 1 day is equals to, same procedure will be repeated here. If the number of days are y, then work done is complete works. But in a one day, the question mark in work, then work is 1 upon y, 1 upon y. But there are no one woman and one man can finish this work. Given in the question, 2 women and 5 men can finish the work. That's why work done by 2 women in one day is equals to 2 upon x. How it is possible? If the woman is 1 and the work her is 1 upon x, then work done by 2 women is a question mark. 2 multiply with 1 upon x, 2 upon x is the work. Same is repeated for a man, but there are how many number of men? 5. Work done by 5 men in one day is equals to 5 upon y. But they are not doing a separately work, they are doing a together work. Therefore, work done by 2 women and 5 men in one day together is equals to 2 upon x plus 5 upon y. But it is a work for only one day. They are working for how many days? Sorry, for the first number. They are working for how many days? 4 days. That's why work done by 2 women and 5 men in how many days? 4 days. 4 days together is equals to multiply it by 4. But we know in 4 days they are a complete one embroidery work. They have finished embroidery work in 4 days. Now they have finished an embroidery work in 4 days. That's why the equation is obtained here. 4 into bracket 2 upon x plus 5 upon y is equals to 1. Why it is 1? One embroidery work is finished, whole work is finished is equals to 1. That's why the equation is 8 upon x plus 4 5s are 20 upon y is equals to 1, which is our first equation. Now for the second equation, we not need to find 1, 2, 3 and 4 steps etc. We write it directly, the equation, using the condition 3 women and 6 men. 3 women and 6 men can finish. It means an embroidery work, finished an embroidery work in 3 days. That's why our equation will become 3 women, there are 2 women, then 2 upon x, 3 women, then 3 upon x, 6 men, then 6 upon y. We multiply it by number of days. Here 4 are the days, 4 days. We multiply it by 4. Here we multiply it by 3 and it is a complete work. 3 3s are 9 upon x plus 18 upon y is equals to 1, which is our equation number 2. Here the two equations are not in form of linear equation. We make it linear. Therefore, assume 1 upon x is equals to a and 1 upon y is equals to b, and we get another equation. We get 8a plus 20b is equals to 1. Third equation, and the next equation is 9a plus 18b is equals to 1, which is equation number 4th. Now we multiply this equation. You have to take b numerically equal the coefficients or a numerically equal. We go for a, that's why we multiply equation 3 by 9 and equation 4 by 8. Equation 3 by 9 and equation 4 by 8. 72 a plus 180b is equals to 9, which is our 5th number of equation. 8 9s are 72a plus 18 8s are 144b is equals to 8 1s are 8. Equation number 6th. We subtract both the equations. Subtract equation 6th from 5th. Subtraction of left hand side, right hand side. 72a plus 180b minus 72a plus 144b is equals to 9 minus 8. Open the bracket. 72a plus 180b minus 72a plus 144b is equals to 1. Plus minus 72a is a cut here. We are using elimination method here. Now 180 minus 144 gives 6 3b. 36b is equals to 1. That's why value of b is 1 upon 36. Now we substitute b is equals to 36 in any of the equation. Suppose in 4th equation. Substitute b is equals to 1 upon 36 in equation number 4th. 4th equation is 9a plus 18b is equals to 1. That's why 9a plus 18 instead of b is 1 upon 36 is equals to 1. Cut is possible here. 18 2s are. Take 2 as a LCM, otherwise shift 1 upon 2 left to right. 9 2s are 18a plus 1 is equals to 2. That's why 18a is equals to 2 minus 1. That's why a is equals to 1 upon 18. A is equals to 1 upon 18. Now what we assume here, 1 upon x is equals to a and 1 upon y is equals to b. Now 1 upon x is equals to a and 1 upon y is equals to b. That's why 1 upon x is 1 upon 18 and 1 upon y, 1 upon b is 1 upon 36. By taking reciprocal, x is equals to 18 and y is equals to 36. Now what is our answer? Therefore 18 days taken by one woman alone to finish the work, and y means the number of days, men 36 days taken by one man alone to finish the work. We write here the answer. Therefore 18 days taken by one woman to finish the work, and 36 days taken by one man to finish the work. Here the second number is completed. Now we go for third. Let's see the last third number from the question number 2. It is also important sum. Ruhi travels 300 km to her home, partly by train and partly by bus. She takes 4 hours if she travels 60 km by train and the remaining by bus. If she travels 100 km by train and the remaining by bus, she takes 10 minutes longer. Find the speed of train and the bus separately. First of all, we need to find the two speeds. One is the speed of train and the speed of bus. Let us take x km per hour is the speed of train and y km per hour is the speed of bus. Here the first sentence says that she travels 60 km by train and the remaining by bus in 4 hours. But to find the remaining, the total distance she travels is 300 km. Ruhi travels 300 km total. Using the first sentence, she takes 4 hours. She means Ruhi. Ruhi takes 4 hours if she travels 60 km by train and the remaining, that is 60 km by train, the total distance is 300, then the remaining is 240 km by bus. The total time is 4 hours. The first of all, we need to find time to travel, time that she travels 60 km by train and the remaining 240 by bus. Time taken by Ruhi to travel 60 km by train is equals to, as we know, the speed is equals to distance upon time. Then time is equals to the distance upon speed. The distance is 60 upon the speed of train is x, time is 4 hours. Same way, time taken by Ruhi to travel, remaining means 240 by bus is equals to 240 upon y hour, but the total time is 4 hours. That's why our equation is 60 upon x plus 240 upon y is equals to 4, which is our first equation. See here, 4 is a common. If we are trying to take common, then 4 common is possible. But we left the space. Take as it is equation 1. If we see the second equation, then we take 4 as a common. We write here in the next number. Then the second condition says that, now what is our second condition? If she travels 100 km by train and the remaining by bus, she takes 10 minutes longer. The second is the most important. Now she travels 100 km by train and remaining is not given, but the total distance is 300 kilometer. 300 minus 100 gives 200, remaining 200 kilometer by bus. Then what happened? C takes 10 minutes longer. C takes 10 minutes longer. 10 minutes longer means 10 minutes more than the previous one, 4 hours and 10 minutes. That's why our equation is time taken to travel train 100 kilometer, it is 100 upon x. There is no need of write second time to finding, plus by bus 200 upon y is equals to 10 minutes longer, 4 hour 10 minutes. Now we convert 4 hour and 10 minutes into the hour. As we know the relation between hour and minute, if minute is 60, then time in hour is 1 hour. Here the 10 minutes only, the 10 minutes question mark in hour, 10 ones are 10 upon 60, 0 cut, and we get 1 upon 6 hour. 10 minutes is equals to 1 upon 6 hour. We are adding 1 upon 6 to 4, 4 6 are 24 plus 1 upon 6, it gives 25 upon 6. The 4 hour and 10 minutes converted into a hour, 25 upon 6. Therefore, 100 upon x plus 200 upon y is equals to 25 upon 6. First of all, we take 25 as a common. 4 upon x plus 8 upon y is equals to 1 upon 6. Now we multiply 6 to 4 and 8. 24 upon x (48 upon y) is equals to only 1, which is our second equation. See our first equation, there is a 4 is a common, but there is a no common we are taking here. That's why first of all we take 4 as a common. Therefore, 15 upon x plus 60 upon y is equals to only 1, which is our first equation. See, what happened here in equation number 1 and equation number 2? In equation number 1 and equation number 2, no one coefficients are equal and they are not a linear equation. We make it by taking 1 upon x is equals to a and 1 upon y is equals to b. The first equation will become 15a plus 60b is equals to 1. Third equation. And the next equation, second equation will become 24a plus 48b is equals to 1. Fourth equation. 60 and 40 both comes in table of 12. Means what? 60 and 48 is equals to 12 5s are 60 and 12 4s are 80. So that we multiply equation third by 4 and equation 4 by 5. Because 12 is a common factor between both. Multiply equation 3 by 4 and equation 4 by 5. 15 4s are 60a plus 240b is equals to 4. There is a no change in our First means there is no common 60 upon A plus 240 upon given as it is, and the next one is 24 5s are 120A plus 48 5s are 48 5s are is again 240, but let us check 240B is equals to 5 1s are 5. Sixth equation. See the coefficient of B numerically equal. We subtract both the equation. Subtract equation 6th from equation 5. Subtraction of left hand side and the subtraction of right hand side. We open the bracket first. 60A plus 240B minus 120A minus 240B is equals to minus 1. The plus minus 240B is cut, remaining 60A minus 120A gives minus 60A is equals to minus 1, minus minus cut, the value of A is 1 upon 60. To find the value of B, we substitute A is equals to 60 in any of the equation, in third or in fourth. We substitute it in third. Substitute A is equals to 1 upon 60 in equation number 3. 15A plus 60B is equals to 1. 15 instead of A is 1 upon 60 plus 60B is equals to 1. 15 4s are 1 upon 4 plus 60B is equals to 1. Taking 4 as a LCM, 1 plus 240B is equals to 4. That's why 240B is equals to 4 minus 1. That's why 240B is equals to 3. That's why B is equals to 3 upon 240. Cut is possible by 80. The value of B is 1 upon 80. It is the value of A in value of B, not value of X and Y. To obtain the value of X and Y, we are using 1 upon X is equals to A and 1 upon Y is equals to B. Now, 1 upon X is equals to A and 1 upon Y is equals to B. 1 upon X is equals to A. The value of A is 1 upon 60 and 1 upon Y is equals to B, which is 1 upon 80. By taking reciprocal, X is equals to 60 and Y is equals to 80. Here the X is the speed of train, therefore the speed of train is 60 km per hour, and Y is the speed of bus. 80 km per hour is the speed of bus. Therefore, speed of train is 60 km per hour and speed of bus is 80 km per hour. Hence, the exercise 3.6 is totally completed here. In next session, we will discuss some important numericals regarding the chapter number 3.